Hello everyone, my name is Ava. Today's topic is bit manipulation. What is bit manipulation and how we can solve some question using bit manipulation. So in bit manipulation, first of all we have to learn about bitwise operator. So first bitwise operator is ampersand. So in ampersand we basically, if we have a given numbers, suppose yeah, these are the binary numbers. So if both the numbers are zeros, means unset, it gives zeros. If any one of the different, it always gives zeros, also gives zeros. These both bits are different, it gives zeros. If both the bits are same, if both the bits are one, basically not same, both the bits are one, then it will give one only. Only. Second bitwise operator is OR. So in OR, basically, again we take same example, 0 1 1 1. If both the bits are 0, then it gives zeros. If one of the bit is 1, no matter other bits, how many other zeros we have or not, if if one bit is 1, then it gives 1. Here we are having 1, so it give 1. If both the bits are 1, it also give 1. So in these three cases, it will give ones only if one bit having is set. One bit is set. Basically, set is used for 1 and set is used for 0. Okay. Now third operator. Third, we have OR. So in OR, we are taking same example, 0 0 1 0 0 1 1 1. In OR operation, if we have different bits, then it is set, otherwise it is not set. Here both the bits are same, so it is not set, that is 0. Here both the bits are different, then it is set. Both the bits are same, then it is set. Both the bits here, both the bits are not same, so it is set. Both the bits are same, so not set. Simple. And next operator we are having not operator for not. In this, if we have a 0 1, then it changes to 1. If we have a 1, then it changes to 0. Simple. So if we are giving an example 1 1 0 0 1 0 1, then doing negation 1 1 0 0 1 0 1, it will gives an output of 0 0 1 1 0 1 0. See here the bits are changes 0. Here 1 changes to 0. Here 0 changes to 1, 0 changes to 1, 1 changes to 0, and go on. So this is not operator. Now we will see go more operator. Fifth operator, which is left shift. Sixth operator, which is right shift. So what is mean by left shift? Basically left shift all the bits to the left. Suppose we are taking an example 1 1 1 0 1 1 0 1. Suppose we have to left shift it by 1. 1 is basically a number which we have to shift shift by basically. So if we have to shift by 1, then we move 1 ahead. This goes to this position, this goes to this goes to this goes to this, and this will neglect. So what will it give? 0. Before there is nothing, so it comes out to be 0, then 1, then this 0 move, then this 1 move, then this 1 move this position, then this 0 move to this position. Simple. So this is a left shift by 1. If we have to left shift it by 2, then what will happen? Left shift it by 2. We have to shift 2 bits. So basically 1 goes here, after that 1 goes to here. Simple. We have to shift 2 bits, so 0 goes here, after that 0 goes to here. Simple. So we have to shift 2 bits, so 1 moves here, 0 moves here, again 1 moves here, this one moves here, others are zeros. This is the left shift by 2. Same as the right shift, we right shift the bits by 1 or the number given as k or ith time. Simple. So in right shift, basically we have to right shift the bits. So taking the same example, it's right shift by 1. So how can we? Now we have to move this bit to 1 step forward, then this bit to 1 step forward, this bit comes here, this bit comes here, this bit come here. So how it will look like? This move to this position, this move to this position, this move to this move to this. No, this is 1 and 1. Sorry, I have went wrong. This is 0. So how it comes out to be? This. And before this there is nothing, so we put 0. So this is the right shift of this bit. When we do right shift operand with 1, then this bit. Again same condition with right shift by 2 or 3, we can say 3. So again 3 bits move first, then we have to move another one, then we have to move another one. We see +1 +1 +1. So how we get it? 1, then this bit comes to this, then this bit come, others are zeros. So this is our answer. Simple. Now we will check. Now we will check whether the number is given is odd or even. So our next topic is how to check a number. How to check number even or odd. Whether the number is even or odd. Simple. Okay. So what is the binary representation of 4? Taking simple number. What is the binary representation of 4? N is equal to 4. So what is the binary representation of 4? 1 0 0. Okay, 1 0 0. So how to check whether the number is even or odd? We have to focus the least significant. We have to focus on the least significant bit, whether the least significant bit is set or not. Simple. Whether we have to check whether the least significant bit is set or not. If it is not set, then the number is even. In case of not set, the number is even. Remember, not set means 0, set means 1. And if it's set, then the number is odd. Let's check another example. Odd number is 7. Let's check 7. What is the binary representation of 7? 4, 5, 6, 7. So what is the least significant? This one is least significant bit, LSB. We have to check whether it is set. Yes, it is set. So it is set. It is odd number. Where in case of 4, it is not set. So it is a even number. How can we check whether the LSB is set or not? So we perform AND operation for that. Suppose our n is equal to 4. Okay. So what is the binary representation? 1, 0, 0. We have to perform AND operation with 1. What is 1 represent? What is 1 in binary? 1. Others are 0. Others are zeros. Okay. So when we perform 1 AND operation, it becomes 0. It becomes 0. It becomes 0. So if we get all the zeros, then our number is even. Okay, simple. Because if we do AND operation between 1 and 0 in above we see that we are performing AND operation between 0, 0, 0, 1, 0, 0, 0, 1, 1. In one case only, when both the bits are set, it only gives 1. Okay, so now we move forward. Even in case of n is equal to 7, we can see 1, 1, 1, 1, 1, 1. Then we have 0, 0, 1, and ampersand. Uh, Let me redraw it. And ampersand 1. Then if we perform AND operation between these, so 1, 1 in AND operation, 1, 1, 1. Then this will give 0. Then this will give 0. Okay. So in the AND operation, there is only one case where it gives 1 when the both bits are set. Okay. So if we get 1, then the number is odd. If we get anyone, that the number is odd. If we get all the zeros, then the number is even. So how to code it? So simple. It is simple. If our number n ampersand 1 is equal to 0, this is 0 condition. If it is equal to 0, then our number is even, else our number is odd. Simple. Okay, now we move forward. So our next topic is swapping two numbers. How to swap two numbers? So let me how to swap two numbers. In general method, we take two number. Sorry, integer a, integer b, defines the value 2, 3. We take a temporary value which is holds the value of one of the variable, and then we change with other. A is equal to b. Here a is equal to 2. Now here a becomes 3, and temp becomes 2. So here b is equal to temp. So basically b is holding the value of 2, so b is equal to 2. Here we can see both the values are swapped. So how can we perform bitwise operator using this? How can we swap two numbers using bitwise operator? So if we are given a is equal to 2 and b is equal to 3, we can perform XOR operation for swapping two numbers. So what will it happen? A XOR B. So what is the binary representation of 2? Binary representation of 2 is 1 0. Binary representation of 3 1 1. So see, in the XOR operation, what we see, if the both the bits are not same, or both the bits are different, then we will change it to 1. If both the bits are same, then it will be 0. So so let's check. Both the bits are different, so it is set. Both the bits are same, so it is unset. 1 0. So a becomes 0 1 right now, which is a decimal representation of 1. Now we will again perform another same operation, a XOR b. So a, what is a here? Here a is 0 1 0 1, and what is b? 3 1 1. So we can check, that is 1 1, both the same, it is unset. Both the bits are different, that is both the bits are different, that is set. So now b become 1 0, which is 2. Okay, now again we perform XOR operation between a and b and put the value into a. So now we will check a. What is a here? Till now a is 0 1 0 1, and what is b? 1 0 1 0. So both the bits are different, so it is 1. Both the bits are different, so it is 1. So now our a becomes 1 1, which is 3. As we can see here, both the values b is equal to 2 now and a is equal to 3. Both the values of a and b are swapped. So this is how we can perform swap operation using bitwise operator, bitwise XOR operator. Simple. What is bit masking? Let's check what is bit masking. What is bit masking? Bit masking. It is a simple concept. It's just like make we make a mask and put it on the number or something else, so that the output, so we get the desired output. Okay, so it is like that. So what is bit masking? So let's check. We have to check the, if we have to check, let me erase this. We have to check whether the ith bit is set or not. So how can we do this? Suppose we have a given number, let's say 1 0 1 1 0 1 1. Yeah, let's indicate 1 from here, because this is the least significant bit, so we can start from here. 0, let me change color if it is possible. Yeah, 0 1 2 3 4 5 and 6. So we have to check whether the third bit, where whether the third bit is set or not. Simple. So what we can do, we can move it one by one. So So we can change the number basically. Sorry. So we can change the number. So it becomes 1 1 1 1 0 1 1. So this is our third bit. We can right shift this bit till it reaches here. Suppose 1 0. Suppose we have to shift it by 3. So it comes 1 2 3. So it comes here. This one comes here. This one. Others are zeros. We have to shift it by 3. And after that we have to make an AND operation with 1. If it will give 1, then the bit is set. If it gives 0, then it is not set. If suppose here it is 0, so 0 1 in AND operation gives 0. Okay, so in this case we get the answer, but we change our original number, moving right shift. Okay, so for that we are not usually perform this operation because it changes the original number. So what we can do, so we take a mask of 1. We take a mask. Suppose we need 0 0 0. For we have to check whether this bit is set or not. For that we put 1 here, others are 0, and we basically perform AND operation on this. So we get the idea of what is this bit, it is set or not. So if both bits are 1, then it will give 1. If both bits are different, it will always give with it will always give 0. Simple. So how this number, how we get this number? So basically we put a mask on the number for the desired output. So let's check how we can make this mask. We take a number, initially it is 1, and we shift it by 3 because we have to check whether the third bit is set or not. So we left shift 1 by 3. So what we give? Left shift by 1, 1 it is here. Suppose these all are 0. So moving 1 plus 1, moving one step left side, then one step left side, then one step left side. So it will reaches here. So 0 1 0 0 0. So we will get third index. This is how we will get the third index of the 1. A number which is having third index only set bit, whilst others are not set. Simple. And performing AND operation, it will give our answer. Simple. Thank you.